download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about the conservation of mass. Now, what we mean by the conservation of mass is that during a chemical reaction, no mass is lost or no mass is gained. Okay, so during a chemical reaction, none of the atoms are destroyed and no atoms are created. So what that means is the mass before the reaction takes place is the same as the mass after the reaction takes place. Okay, so let me just write a balanced equation for you here to show you what I mean. Okay, so here we're reacting sodium with water. Okay, and if you remember from our group 1 elements video, that makes sodium hydroxide plus hydrogen. Okay, now that right here, this, if we counted up all the atoms or the individual atoms that were on the left and on the right, you'd get 2 lots of sodium and you'd get 4 lots of hydrogen and you'd get 2 lots of oxygen on the left, so as the reactants, and you'd get 2 lots of sodium, you'd get 4, because 2 here and 2 here, so 4 lots of hydrogen, and you'd get 2 lots of oxygen there. Now if you don't know what I did there, please watch my balance and equation video and that will help you out. Okay, so what you can hopefully see is that the amount of atoms on this side as the reactants is the same as the amount of atoms on this side, the products. None of these atoms have been lost, none have been destroyed, none have been gained during this chemical reaction, and that is why there is no mass lost or gained in the chemical reaction. Okay, chemical reactions are just about the swapping, if you will, of formation of the atoms. So sodium here joins with the oxygen and hydrogen here, for example. Okay, but they don't get lost and they don't get destroyed and nothing is gained. So what we mean by the conservation of mass is that during a chemical reaction, no mass is lost or gained. And that is because no atom is destroyed or gained in a chemical reaction. So the mass before is the same as the mass after. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers and so much more. The link is in the description. Now there are 2 occasions where it might appear the mass has changed, and I'm going to take you through those 2 occasions now. Okay, so first of all, the mass might appear to decrease, go down, because a gas is formed which then escapes from the container. So let me explain that, and I'm going to explain it using an example where we're going to react sodium with water. Okay, and if you've watched our alkali metals video, you will know that this produces sodium hydroxide and hydrogen. Okay, so the way that I'm going to show this is going to work is that I'm going to draw some scales. Okay, and what I'm going to do is I'm going to put a bowl of water on those scales, and then we're going to add in some sodium. Okay, we're going to add sodium into that bowl of water. Now what we're going to do then is we're going to take the recording from the scales and say, for example, that now reads at 50 grams. Okay, now we know, looking at this equation, that what is going to be formed when we add sodium with the water is sodium hydroxide, but more importantly for this example, hydrogen as well. Okay, so I'm going to now draw a second picture, and again it's just a lapse in time. Okay, so time has now passed, and what happens in this reaction is sodium hydroxide is starting to form in the bowl. So sodium hydroxide is starting to form in the bowl, but also hydrogen gas is starting to form. Now we know it's a gas, so it's going to escape from the container. Okay, so all the hydrogen gas that's being formed is going to escape from the container. So because the hydrogen has escaped from the container, the scales are going to go down. Okay, so for example, these scales might read 45 grams because we've lost the hydrogen gas from the container into the atmosphere. So in this example, it appears like the mass has gone down in the reaction. Okay, it appears like mass has been lost. But remember, we can't lose mass, i.e. we can't really destroy or gain atoms, but those hydrogen atoms have escaped. So it has made the balance, the scale, go down, but that is only because the scale is not measuring the hydrogen gas that's in the atmosphere. Okay, so it looks like in this reaction that it's lost mass, but it hasn't. It's because a gas has been produced and the gas has escaped from the container. Okay, now there's a second reason why a mass may appear to change, and that is the mass may appear to increase if atoms from a gas in the atmosphere have been added. Okay, now to explain this reaction, I'm going to use potassium. Again, another example from our Group 1 alkali video, potassium plus oxygen. Now, you should know if you've watched that video that potassium plus oxygen forms a potassium oxide. If you didn't know either of these two reactions, I suggest you go back and watch that Group 1 elements video. Now, the same thing again, I'm going to put this on a scale. Okay, and I've got a beaker of potassium. Okay, so this beaker contains potassium. Now what I'm going to do is I'm going to force that potassium to react with the oxygen in the air, maybe by heating it up. Okay, so I'm going to force that to happen. But before that, actually, we didn't take a reading. So imagine this is 50 grams, because what we're measuring is we're just measuring the beaker and the potassium. So now we're going to force that potassium to react with the oxygen in the air, and what's going to be formed in the beaker is now potassium oxide. However, what's going to happen is the scales are going to show that the mass has gone up. Okay, now we haven't created mass here, we haven't created atoms, but it is because the oxygen from the air has binded with the potassium in the beaker to produce potassium oxide. So now this container contains both potassium and oxygen together as potassium oxide, so the scale has gone up. We've not created the atoms, but the atoms have come from the atmosphere. So originally these atoms here, oxygen atoms in the atmosphere, they weren't being measured by the scale, but when they're reacted with potassium as potassium oxide, they are measured in the scale, so the scales appear to go up. Okay, so very quickly, just to summarise those points, if the mass appears to go down, it's because a gas was produced and has escaped. If the mass appears to go up, it is because a gas is used in the reaction and that gas has been added to the reactant. Okay, and that's why it may appear to go up. So what I'd now like you to have a go at is answering these questions here, and then we'll go through the answers together. So pause the video now. Okay, so let's run through the answers. So number 1, what is the law of conservation of mass? Well, the important thing of this law is that no mass is lost or gained in a chemical reaction. And you can also, of course, write that as no atoms are destroyed or gained in a chemical reaction. Okay, now it may appear to change on 2 occasions, and that's it, with a gas being formed and escaping, or a gas being used in the reactants and then being added. But no mass is lost or gained in a chemical reaction. Number 2, look at the reaction below. Explain how you know it is not balanced. Well, quite simply, we know that there are 2 chlorine on the left. So as a reactant, we've got 2 chlorine, whereas the product, we've only got 1 chlorine. Therefore, they're not balanced. Number 3, if 20 grams of sodium is used and 110 grams of sodium chloride is formed, what is the mass of chlorine used? Well, we've got 20 grams here, so this is 20 grams, and this here is 110 grams. Now, we know that no mass is lost or gained in a chemical reaction, therefore, the reactant's mass is going to be the same as the product's mass. So that means if this side, the right side, the product side is 110, then the reactant side also needs to be 110 as well. We've got 20 grams of sodium. That leaves 90 grams, therefore, of chlorine to make it 110. So it will be 90 grams. And then, if you had 90 and a 20, that's 110. And this side is 110. So then, both reactants and products are both 110 grams. Question 4 below is a simple equation for the reaction. Calcium carbonate plus hydrochloric acid produces calcium chloride, carbon dioxide, and water. Balance that equation. So what I've done is I've written that equation out here, and we're going to balance it. And if you don't know what I'm doing right now, please go back and watch that balancing equation video where I write it in more detail. So first I'm going to write out the atoms that we've got. CaCOOO, and I'm going to circle that to show that we cannot change or interfere with any of that. Then we've got HCl. Then we've got calcium and chlorine, 2 chlorines. Then we've got carbon dioxide, COO, and then we've got H2O, so 2 H's and an O. Now we need to count the atoms on each side. So calcium here is 1, carbon here is 1, and there's 3 oxygens, 1, 2, 3. There's 1 hydrogen, and there's 1 chlorine. And then on this side, calcium, there's 1, chlorine, there's 1, 2. Actually, we'll do it, make sure we do it in the same order. So here, calcium, we've done carbon here, so we'll do carbon next. There's 1 carbon there. Oxygen, there's 1, 2 oxygen. Hydrogen, there's 1, 2 hydrogen. And chlorine, oh sorry, actually I've missed that oxygen there, haven't I, because I've not written it very well. H2O, so there should be 3 oxygen, apologies. And chlorine, there's 1, 2 chlorines there. Okay, so calcium are balanced, carbon are balanced, oxygen are balanced, hydrogen and chlorine are the ones that aren't balanced. We've got 2 hydrogen this side and 2 chlorine this side, but only 1 and 1 on this side. So what can we do here to get 2 hydrogens? Well, there's 1 hydrogen here, so we may double them. So HCl, get 2 of them. That now makes 2 hydrogen and 2 chlorine, which has now balanced the equation. So all we have to do is add 2 in front of our HCl here, and we've balanced that equation. So all you should have done is added 2 here, and you would have been correct. If you didn't get that right or didn't understand what I just did, again, please watch that balancing equation video. And finally, explain why the mass of this reaction appears to decrease. Well, looky here, carbon dioxide. We know that carbon dioxide is a gas. So this could have escaped after the reaction, which would have made the mass appear to decrease. So with these types of questions, if you're looking for the mass is going to decrease, then you're looking for a gas in the formula. As a product, if the mass would have increased, what you'll be looking for is a gas in the reactants, and that's how you answer the question. You know, if it appears to decrease, then it's always going to be the answer because a gas was produced and escaped. If it appears to increase, then the answer is always going to be a gas was added and has now been added to the reactant. So we've now looked at the conservation of mass there, and we've also slightly looked at balancing equations again, and what the conservation of mass actually means for chemical reactions. So you can now really move on to the quiz and answering any exam questions. If there's anything you didn't understand in the video, then please do get into contact with one of our tutors and they will be happy to help.